Hello dear students, we will solve some numerical problems related to kinematics today. At first let us review the related formulas. Distance moved in nth second is given by Sn is equal to u plus a by 2 into 2n minus 1, where a is acceleration and u is initial velocity. Second formula, velocity of particle B relative to particle A when theta is angle between A and B vectors is given by VB minus VA is equal to under root VA square plus VB square minus 2 VA VB cos theta, and angle of this relative velocity with vector VA is given by this relation, beta is equal to tan inverse VB sin theta upon VA minus VB cos theta. Third, when the projectile is thrown at an angle theta with velocity u, then its range is given by this equation, r is equal to u square sin 2 theta upon j. H max is given by u square sin square theta upon 2j, and r max is equal to 4h max when theta is 45 degree. Fourth number, for projectile thrown horizontally, time period t is equal to 2h upon g. Second, r horizontal range r is equal to u into t. Third, velocity of the particle at any instant t is given by b is equal to under root u square plus gt square, and beta is the angle between the resultant velocity v with horizontal given by this relation. First question, a stone on the top of a vertical cliff is kicked horizontally with initial velocity 9 meter per second. If the cliff is 200 meter high, calculate time taken by a stone to reach the ground. Second, how far from the bottom of cliff the stone hits the ground. Now solution to question 1. Here, suppose this is cliff or tower. Cliff, and a stone is thrown horizontally with velocity 9 meter per second. Then we have to find first time taken to reach the ground, means time taken to reach from A to B. Second, horizontal range is what? Suppose AB, this is C. AB is H is equal to 200 meter. Height of this tower is 200 meter. Now we know for the projectile thrown horizontally, for the projectile thrown horizontally from the top of a tower is given by, time period is given by 2 under root, time period is given by under root 2h upon g. So it will be 2 into h is 200, and if we take g as 10, it will give 6.32 second. Second one, horizontal range, this one, horizontal range will be equal to u into t. U is 9, t is 6.32, so horizontal range will be 56.32 88 meter. Next, question number 2. Question is, a swimmer's speed along the river is 20 km per hour and up the stream is 8 km per hour. Calculate the velocity of stream and the velocity of swimmer in the still wire. Solution to question 2. Given velocity of swimmer along the flow of water means stream, along the stream of river water. This will be velocity of river plus velocity of swimmer is equal to 20 km per hour and velocity of swimmer up the stream, means in opposite direction, up the stream, that is opposite direction, in opposite direction. So this will be V swimmer minus V river, swimmer minus V river is given to be 8 km per hour. So we have to find the velocity of swimmer and we have to find velocity of river. Now 20 V swimmer minus V river is 8. On adding we get 2V swimmer is equal to 28. Therefore, V swimmer will be equal to 14 km per hour and therefore V river will be equal to 14 minus 8 means V river 14 minus 8 means 6 km per hour. So the water is flowing with velocity 6 km per hour and swimmer is swimming at 14 km per hour. Next question number 3. The question is, a projectile is thrown with velocity 300 meter per second at an angle of theta with horizontal. Find the value of theta so that the horizontal range is maximum. Find range and time of flight. Solution: given for the projectile thrown at angle theta with velocity 300 meter per second, we have to find theta for maximum range and R maximum, then, and we have to also find the time of flight. For the projectile, . thrown at an angle theta with horizontal. Range is equal to u square sin 2 theta upon g. Range will be maximum when sin 2 theta is 90. For maximum range, sin 2 theta should be maximum. Sin 2 theta should be maximum and its value will be 1. Therefore, theta must be 45 degree. Then, from this relation, range will be maximum equal to u square upon g. U is 300 square upon 10. It will be 9000 meter. Second one, time of flight is given by 2u sin theta upon g. It will be equal to 2 into 300 sin theta is 45 upon 10. So we get time of flight as 42.42 second. 42.42 second. Question number 4. The question is, a projectile is thrown with velocity 500 meter per second at an angle 30 degree with the horizontal. Find the horizontal range, maximum height and time to reach the greatest height. Solution to question 4. Given suppose this is the projectile thrown at 30 degree with horizontal with velocity 500 meter per second. We have to find range or we have to find maximum vertical height h max and time to reach the greatest height. Solution. First, this is the projectile thrown with velocity 500 meter per second at an angle 30 degree with the horizontal. We have to find the horizontal range r, we have to find maximum vertical height h max and we have to find the time to reach the greatest vertical height, suppose that is t dash. Solution. Range r is equal to u square sin 2 theta upon g. Putting the values, we get r as 66,650.6 meters. Now h max is given by the relation h max is equal to u square sin square theta upon 2g. Putting the values, we get 3,124.99 meter, which is nearly 3,125 meters. Next, third part, time to reach the greatest vertical height is given by time to reach greatest height is given by t dash is equal to u sin theta upon g. U is 500, sin theta is sin 30, 1 by 2, sin 30, 500 into sin 30 upon 10, which gives 25 seconds. Next question number 5. A batter hits a baseball with velocity 37 meter per second at angle 53 degree with horizontal. Find the magnitude and direction after 2 seconds. Solution to question number 5 given. This is the projectile thrown with velocity 37 meter per second at an angle 53 degree with the horizontal. We have to find the magnitude and direction at t is equal to 2 seconds. First we find the time of flight. Flight is, suppose we denote time of flight as t. T is equal to 2u sin theta upon g, 2 into 37 into sin 53 upon 10, which gives 4.56. 4.56 seconds. Its half is, therefore t dash is equal to time taken to reach greatest height will be equal to t by 2, which is 2.28 seconds to reach the greatest height. Means at 2 seconds the ball has not reached to greatest height, that is it is moving up. Hence the ball is moving up because t is less than t dash, because t is less than t dash. Therefore v vertical will be equal to u vertical minus gt. U vertical is u sin 53 minus u vertical minus gt, 10 into t. So we get 37 sin 53 minus 20, which gives 9.55 meter per second. 22.27 meter per second. Also u x will be equal to u cos theta 37 cos 53, which gives 29.55 meter per second. Therefore resultant velocity will be u x square plus v y square, it will be equal to 29.55 square plus 9.55, which gives resultant velocity as 24.23 meter per second. Angle between ux and v will be given by tan inverse dy upon ux, tan inverse dy 9.55 upon 29.55, which gives 23.21 degree. Next we take question number 6. A car traveling with speed 15 meter per second is braked and slows down with uniform acceleration. After moving 88 meters, its velocity reduces to 7 meter per second. If the car slows down with the same rate, after what further distance it will stop? Solution to question 6 given. Suppose this is car at point A, its velocity is u is equal to 15 meter per second. Due to application of brakes, it retards uniformly, so that from A to B after moving distance 88 meter, its velocity reduces to b1 as 7 meter per second. So we have to find the further distance s2, so that the car stops, means from B to C B2 becomes 0. Retardation is same throughout. Solution. From A to B, we have b1 square is equal to u square plus 2a s1. Therefore, a will be equal to b1 square minus u square upon 2 s1, which gives retardation 7 square minus 15 square upon 2 into 88, which gives minus second square, 1 meter per second square. Minus indicates that the car is retarding. Now from B to C, this is final velocity and this is initial velocity. Therefore, we can write b2 square is equal to b1 square plus 2a s2, b2 square is equal to b1 square plus 2a s2, b2 is 0, b1 is 7 square plus 2 into a is minus 1 into s2. So 49 is equal to 2s2. Therefore s2 will be equal to 49 by 2 means 24.5 meter. Next question number 7. A stone is projected horizontally at 20 meter per second from the top of a tower. Calculate its position and velocity after 3 seconds, neglecting air resistance. So, solution to question 7. Given this is tower, object or stone is thrown horizontally with velocity 20 meter per second. It will reach to ground, will be moving towards this path. We have to find position and velocity at t is equal to 3 seconds. Is what? Now solution. Suppose after t second, t is equal to 3 seconds, the body reaches to point P, then the vertical height will be h1. After t is equal to 3 seconds, vertical height moved is given by t is equal to under root 2 h1 upon g, which gives t square is equal to 2 h1 upon g, means h1 is equal to g t square upon 2. G is 10, t is 3 upon 2, which gives 45 meters. Thus the stone has moved vertical height h1 equal to 45 meters. So at point P, here y is 0, this is Vy. At point P, therefore at point P, resultant velocity will be equal to t square u square plus vt square. U is 20, 20 square plus 10 into 3 square, which gives 36 meter per second. 36 meter per second. angle between V and horizontal is given by beta is equal to tan inverse Gt upon U. Tan inverse G is 10, P is 3, U is 20. So angle will be 56.3 degree. Next question number 8. The question is, a body falls freely from the top. A body falls freely from the top of a tower, and during its last second it covers height 25 meters. What is the height of tower? Solution to question 8. Given HN is equal to 25 meter. This is height covered in nth second. We have to find height of tower. We know distance or height moved in nth second. Is given by Cn is equal to U plus A by 2 N minus 1. In this case, therefore, in vertical case, Hn will be equal to U plus A becomes G upon T, G upon 2 N minus 1. U is 0 for free fall. Hn is given to be 25 meters plus 10 upon 2 N minus 1. So it is 5 is equal to 25 upon 5 means 5 is equal to 2n minus 2. Therefore, n will be 3 seconds. Therefore, height of tower will be equal to ut plus half gt square. U is 0 plus half 10 into 3 square, which gives 45 meters. So the height of tower is 45 meters. Next question number 9. The question is, a projectile is thrown at 30 meter per second at an angle 60 degree with the horizontal. Find the magnitude and direction after 5 seconds. Solution to question 9 given. This is projectile thrown at 60 degree with horizontal with velocity 30 meter per second. we have to find the magnitude and direction of velocity. V is what? At t is equal to 5 seconds. Our solution: time taken to reach the greatest height is t dash is equal to u sin theta upon g, which will be 30 sin 60 upon 10, which is nearly 2.26 seconds. Thus, given t is greater than t dash, hence projectile will be falling down. Means if this time were less than t dash, then it would have been moving upwards, but it is greater than t dash, therefore it will be falling down. Suppose it has reached to point P, then at this point it has velocity Vx and vertical velocity Vy. Therefore the vertical velocity will be equal to, therefore at point P vertical velocity will be Vy is equal to u y minus gt. Uy is 26 minus 26 or minus uy plus gt. 26 plus 10 t is 5 seconds, which gives 24 meter per second. Therefore, resultant velocity at point P will be what is range? We have to find H maximum equal to 18,750 meters. Next, horizontal range H max. Next we find the maximum vertical height. H max is equal to u square sin square theta upon 2g. Therefore 500 square sin square theta means sin square 30 upon 2 into 10 means g means 10, 2 into 10, which gives 3,125 meters. Third part, again r is equal to u square sin 2 theta upon g. Therefore, r into g will be equal to u square sin 2 theta. Because r is same and g is constant, so when u is minimum, sin 2 theta should be maximum. So u minimum square, then sin 2 theta should be maximum, and because sin 2 theta maximum will give 1 when theta is 45 degree, then it becomes u minimum square into 1. Therefore, u minimum will be equal to under root r into g. R has been calculated in first part as 18,750 and g is 10. So u minimum comes to be 433 meter per second. Means with this minimum speed, range will be same as in case 1. Next question number 11. Question is, a man wishes to swim across a river which is flowing at 2 km per hour. If the person can swim in still water, still means sthir, at rest. Still means at rest. If the person can swim in still water with velocity 4 km per hour, then in which direction he should start? He should then in which direction he must swim to reach just opposite point of river. When will he reach? The width of river is 600 meter. Solution here given. Suppose this is river. Width of river is 600 meter, which may be written as 0.6 kilometer. River is flowing at speed v. River is 2 km per hour. The person wants to reach from point A to point B. Point B, which is just opposite the point A. The person wants to reach from point A to B, which is just opposite to point A. Then in which direction the person should start swimming? Now, as the water is flowing in this direction with velocity Vr, the person must start along this direction so that the resultant velocity of person and velocity of river must be along this. Means if the person swims in this direction, if the person swims along this direction with the velocity v, man is equal to 4 km per hour, then the velocity of person plus velocity of river must be equal to the velocity of, then the vector sum of velocity of river, then the vector sum of velocity of man, then the vector sum of velocity of swimmer, and the velocity of river must be equal to the velocity along AB. Suppose this angle is beta. Then to reach from A to the opposite point B, of river, the person should start, the person should swim along AP, such that vector sum of V swimmer plus V river is equal to V along AB. From figure, sin beta is equal to perpendicular upon hypotenuse, means PB upon AP, which is 4, then PB is 2, which is 2 upon 4, 1 by 2. Therefore, beta will be equal to sin inverse of 1 by 2, which gives 30 degree. Therefore, this angle theta will be equal to 90 plus beta, which is 90 plus 30 means 120 degree from the direction of flow of river. Now, V is equal to d upon t. Therefore, t will be equal to d by v. T will be equal to d is 0.6 kilometer, 6 kilometer upon v is also from figure, resultant velocity v will be equal to this square minus this square. So v swimmer square minus v river square, 4 square minus 2 square, which gives 16 minus 4 means root 12, which 3.46 kilometer per hour, which is resultant velocity. Therefore, V will be equal to d upon t, which gives time taken as d by v. D is 0.6 kilometer, d is 600, which is 0.6 kilometer, upon v is 3.46 kilometer per hour, which gives 0.173 hour, which is 0.173 into 60 minutes, because 1 hour has 60 minutes, which gives 10.4 minutes. So, the person will reach from point A to point B in 10.4 minutes.